Okay, everyone, stop talking, pay attention here. Guys, we are going to revise for the thermal chapter today, guys. And inside the thermal chapter, there are going to be a few things you need to know. I'm going to break it down by question. I'm going to break it down into question by question on what are the things you need to know. Looking at the first question here, obviously you need to know how radiation occurs. You need to understand how to calculate the thermal heat energy here as well. So without wasting any more time, let's go for a quick one, guys. In terms of radiation, guys, whenever they talk about radiation, right? Whenever I talk about the radiation part here, you have to understand how black, white, silver are going to behave depending on different situations. And guys, we all know this, guys. Black is the best or worst absorber of heat. It is the best absorber of heat, right? It is, in terms of reflector, is it the best or the worst reflector, guys? It is definitely the worst reflector of heat. And in terms of emission, guys, emitter, guys, is it the best or the worst emitter? It is definitely the best. And for those who do not know what an emitter is, it is basically the ability to radiate heat, meaning to say, if let's say, for example, I have a black color can versus a white color can, and I pour hot water into both of them, what's going to happen is you're going to detect a higher temperature here. You're going to get a higher temperature here because it is able to radiate heat out the best way, guys, right? And of course, so for white color, it will be the exact opposite, right? The heat that is inside here will be reflected back in. That's why it's a very little amount of it is emitted outwards, guys. This is how you're supposed to understand it. So if you want to take this into a real life scenario, let's imagine today all of you guys here decide to go to the beach, and then one of you guys is wearing black and the rest of you guys is wearing white. Obviously, the guy that is in black is going to feel much more hotter simply because he absorbs more heat from the sun, and the shirt emits more heat to the body, guys. So always remember, black is the best absorber and the best emitter of heat, whereas it is the poorest reflector of heat, guys. These three things here, right? So this thing I think everyone should know by now. Let's talk back a little bit on the heat energy formula. Jiabao, what's the formula for heat? Good. Q is equals to mc theta. Now, guys, Q is basically supposed to be your heat energy, which is measured in joules. M is obviously your mass, which is in kg. C is specific heat capacity. What's the units of specific capacity again? Anyone can tell me? Good, excellent. Joules per kg degree Celsius, whereas this one is change in temperature, guys. This is not temperature, it is the change in temperature. And because it is change in temperature, obviously it is measured in degrees Celsius, right? These guys are late. All right, hurry up, word.
Hey, Daddy.
Daddy? Daddy, is that you? Daddy? Hey, hurry up, wait, sit down, hurry up. Fill up the seats. I think it's going to be a full house today, guys. It's going to be a full house today.
On the house.
On near the house. Okay, now, guys, I want to emphasize this thing here, guys. Everyone pay attention to this. In terms of your IGCSEs, they love to test you on specific heat capacity. Now, for those who cannot remember what unit it is, you are definitely not expected to memorize it, because in order to remember what unit it is, you just need to make C the subject, guys. If you make C the subject, of course, you must have certain degree of mathematical skills. If your algebra is shit, then it's game over for there already, guys. Right, this is just making it a subject, right? From here, if you make the subject, you know that this is heat energy, which is in joules, this is kg, and this is in degrees Celsius, guys. That's why you get a unit of joules per kg degrees Celsius. Never memorize it. Try to understand how you got there, right? And in terms of specific capacity, in your IGCSEs, they love to ask you to explain what is the definition of specific capacity as well. Now, looking at the formula itself, you can more or less bullshit your way through the whole statement already, guys. Pay attention here. Specific heat capacity is the amount of heat energy needed to raise 1 kg of a substance by 1 degree Celsius. This is a very important statement now, guys. They always ask this, I better make sure you know how to explain it in terms of the formula. I repeat, specific capacity is the amount of heat energy needed to change 1 kg of a substance by 1 degree Celsius. Okay, follow the formula, you will be able to get your free 2 marks there. All right, and then the final thing that you need to know for this question number 1 is basically the power formula. Power is essentially energy over time, and the efficiency formula is always output over input multiplied by 100%. Now, guys, in terms of this efficiency here, if you ever get an efficiency that is more than 100%, let me tell you, you are wrong for sure. Oh, can you repeat that again? Which part do you want me to repeat? The specific capacity one, is it? Okay, I repeat, specific capacity is the amount of heat energy required to change 1 kg of a substance by 1 degree Celsius. Okay, do you get that? Specific heat capacity is the amount of heat energy required to change 1 kg of a substance by 1 degree Celsius. Okay? Yeah, okay, good. Okay, then back to this part here, guys, in terms of the efficiency. If you ever get 100% or more, you are definitely wrong, because contrary to what your mama told you, there is no 100% in life, right? I know. Oh my God, can you open the door? Output over input times 100%. Welcome back, Noval. Grab a seat anywhere your heart desires. Hey, hello, Wilun. Welcome. Grab a seat. Yeah, anywhere. Oh, I guess you guys will have to split. One guy can sit here and one guy can sit here. This is the favorite seat. Hey, don't say that, a little bit low. Yeah, but she's always missing. Where is she? Where? Mana orang? Late as usual. Good. Speak of the devil. Hey, William, do you mind? Guys, yep. The end. Oh my God, you're back. You're back. You're back. Yay. Hey, I reserved your favorite spot here already, Liam. Welcome back. Yeah, welcome back. Okay, I don't think there's any more place where you are. Who else? Who else is missing? Orange markers. Yeah, I know. I mean, like in the physical class, by right? Yeah. Okay, but anyways. Oh yeah, what was I saying? Right, back to this last time. There is no 100%. Anytime you get 100%, it is definitely wrong. Most likely it's because you put input over output instead of output over input. But if you written down the proper units, hey guys, this output could be in terms of power, it could be in terms of energy, it could be in terms of energy, it could be in terms of heat, it could be anything, guys. So don't limit yourself to only output power over input power, or output energy over input energy, guys. It can be literally anything, you know, like the food that you eat and the shit that you come up also is, you can be calculated in terms of efficiency. So yeah, that's just a wow statement. But yeah, guys, anyone with any questions with anything I have mentioned so far? It's power, bro. Energy over time, bro. This you don't know. You want me to beat you again?
Okay.
What?
It's okay, I'm really used to the
Yeah. Anyone that comes to physical class will receive some form of physical abuse. Huh? What? Oh, what the? Yo, that's the border. Okay, guys, any questions? If you have no questions, please copy down all the useful information here, whichever you deem necessary, and start attempting the first question, guys. Everyone got their paper, right? Start attempting the first question. Oh, you have exactly 8 minutes to attempt everything. Then we're going on to the next part. 6.21.
Oh yeah. She got inside. You inside, Wow.
Xe anh vậy. Hi, Willen. You're stuck. You're stuck. Please going out.
Oh yeah, just the one.
Are you? Are you stuck with the question?
What is the one that says like?
Alright, 10 pixels.
I don't know.
Oh, don't be shy, because it doesn't work with this bunch of animals at the back.
So you better not talk to each other.
Huh?
I used to stay here.
Shit. Every time it's the sun now, which one is not the sun?
What?
He's here.
Oh, I don't. Hey, Willen, can you? Yeah.
Hey, it's not outdoor duty anymore, Natalie.
Yay. Oh,
Oh,
God.
yeah.
Now you're gonna be, hey, 这样。哎呀，害你们全部坐进来，等给他坐。
What is this?
Rubber.
What is sun?
What? What sun?
Hi. And die.
I mean sun.
Dies.
Oh, energy resources.
And dies is not the sun, it dies and then it gets wish.
Yeah, please attempt it. I'll explain everything in 6 minutes.
Pen. Pen, you're using pen. Yeah.
It's wrong, by the way.
Is it geothermal? Is it one? Is it?
The
Oh my God, it's
sun
geothermal.
is
Yeah, geothermal is the land one. I think it's sufficient of reason now. We don't measure that.
Oh, sorry. Cole was correct. Sorry.
Excuse me.
My bad. I didn't read the question properly. Sorry. My bad. Specific capacity is the amount of energy needed to change 1 kg of silver. Yes, very good. That is correct, Sydney.
Why the two grade of copper?
Why? Why is it? Why?
Because
Good.
it's the best meat from after.
Why painted black?
Get the best
Why
meat
painted
from
black?
Exhaust your head. Ah. Em la master. Shut up, la master. All right, everyone, you had your time to try it out. Let's go through each and every one of these questions one by one, guys. Now, the first question here, I actually did not look through this, but guys, this is basically the source of energy. So guys, it could either be renewable or non-renewable. It could either be from the sun or not the sun. Guys, I want you all to know any energy under the sky is going to be from the sun, except for three only, guys. What are the three energies that are not from the sun? Hold your head. You know how coal is made or not? From the compression and everything of the dead animal. You have to decompose what? And then before that, they were living animal.
Decomposer, yes.
Yes, which gets energy from photosynthesis, which is also from the sun. Okay, guys. Yes, that's exactly what I just said. Everything under the sky belongs to the sun, except for three only, guys. The first one is definitely going to be nuclear. Where is nuclear coming from? Nuclear is coming from uranium, plutonium, right? All these are going to be radiation already, right? So they do not derive energy from the sun. What's the second one?
Wind.
Wind is deriving energy from the sun through convection as well.
So why is it not wind then?
Wind is from the sun.
That's why you say it's cold.
No, what?
Huh?
Oh, sorry. Dude, my question is which energies are not from the sun? You're telling me why the energies are not wind here, bro. It's two different things.
Why is it not from the sun? Huh? I'm so confused. Why you say quickly?
What? The wind is from the sun.
Yes.
It is from the sun. It is. This is also, and this is also. What? Who says singular? All these are from the sun, one. Coal, electric, hydroelectric, and wind are all from the sun. Hey, pay attention, everyone. Listen up. There is only three energies that do not derive from the sun. Number one is nuclear. Number two is geothermal. For those who do not know what geothermal is the ground's heat energy, which is from the core, right? That is geothermal that does not come from the sun. And the third one is going to be tidal, guys. It's going to be tidal waves. Tidal waves do not derive energy from the sun. It derives energy from the gravitational pull of the moon. Guys, that is the reason why when you go to the beach at night, the tide is high, and then at the morning, the tide is low. It's because the position of the moon is rotating differently already. Right. Hydroelectric is from the evaporation of water that is stored into the dam. Then the water rushes down the what's it called, the turbine to spin it. It converts kinetic energy to electrical energy. Okay, I repeat. Hydroelectric, right, is energy from the evaporation of water. The water that is from the lake will be evaporated and then rained down and collected on the dam. The dam will allow one stream of water to flow that spins the turbine. So that is from the sun as well. Sorry? Wind. Okay, wind. Huh? Wave. Wave. Oh, wave is. No, hydroelectric could be the turbine spinning, the one that is like the water flowing down and spinning the turbine one. It doesn't necessarily have to flow down as well, but it must be from a higher stream. When the water flows, it will spin the turbine that converts kinetic energy to electrical energy. Yes, it is from the convection of heat. You know how wind happens? So let's imagine this is a piece of land, right? Then the sun is here, right? What's going to happen is this sun is going to heat up this specific spot. This spot will be so hot, it starts heating up the air particles. These air particles will go up. The heated air particles always goes up, right? Because according to convection, when you heat it up, the volume expands. When the volume expands, the density decreases. And because of that, it goes up. So what happens is the cooler air circulates downwards. And this thing will keep repeating itself, creating a convection current. Yes. Yes, we will go more. We will repeat this in the intensive class, so don't worry, guys. We'll go more in depth on this. Okay, everyone. Any other questions from this part here? Okay, yeah. So the answer is these three: coal, hydroelectric, and wind. All right. Now the next part here, figure 4.1 shows a solar water heated panel on a roof right, of a house, cold water flows into the copper pipes, which are heated by solar radiation. Guys, I want you to know anytime there is anything related to heat, it is due to infrared. Now, why is the fire hot? It's because there's infrared in it. Why is the sun hot? It's because there is infrared in it. Anytime to do with heat is going to be infrared, guys. And the hot water flows out of the tube and stored in the tank. Explain why the tubes are made of copper and plated black. So you need to explain why, right? Why is it made of copper? It is the best conductor of heat. Then why is it painted black? Because it is best absorber of heat, guys. So you're supposed to mention these two things. If you want to structure it, you could say that copper is one of the best conductors, and then you could say that it is painted black because it is the best absorber of heat. It's the best absorber of heat. Right. But anything along the lines is going to be acceptable.
The answer say radiation and infrared.
Best absorber of infrared radiation, which is heat.
But they underline heat. I mean underline radiation and infrared.
It is the same thing. Trust me, I've done this 1,000 times. Sorry, what do you say? Oh, you only work black, Oh no, you will not. It will not. This is not English test. Okay. And then moving on to the next part here, right? Okay, stop talking, everyone. Hello, stop talking. In 5 seconds, 0.019 kg of water flows and it increases from this to this. First and foremost, I know that the change in temperature is supposed to be 52 degrees Celsius, right? And obviously this is my C, this is my time, this is my M. And they want me to find my Q here, right? Q is essentially going to be MC theta, right? Which I have all the information here, is 0.019 multiplied by 4,200 multiplied by 52. Press that in your calculator and you'll get a very weird number, 414 something joules, right? But remember, you can only write 3 significant figures in your answer, guys, meaning to say, if you wrote anything more than this, it is wrong already. The minimum is 2, the maximum is 3 significant figures, meaning to say, even if you wrote 4100 joules, it is acceptable, guys.
So you check your answer, I think it's 4150.
Yeah, that's how powerful, man.
4150.
Yeah, I thought they have to.
0.019 times 4200 times 52. 4150.
Yeah.
Exactly, that was a test. If it's that. Oh, yeah, then we. Oh my God.
No, it's 4-1. You have to move.
Correct, right? If it's 5.
No.
But anyways, it doesn't matter, right? My recommendation is you always make it into 3 significant figures because that is the more accurate answer, guys. You know, the more significant figures you have, the more accurate it is, right? Yes, everyone. Yeah, it's double in really, but that's not.
Not accurate at all.
Yes, that is. I know. Okay, then finally they say that the efficiency is 70%, right, guys? And if the efficiency is 70%, they want you to calculate the power of solar radiation incident on the panel, which means to say this 41500 is the 70%. Oh, sorry, is the input or the output?
Input.
It is the
Isn't that the water?
incident on the panel, though. This, we are looking for the input. It means to say this is the output, right? We are looking for the incident onto the panel, right? Which is the input energy, right? So from here, efficiency is equals to output over input multiplied by 100%. From here, it's basically 70 is equals to 4150 divide by your input. I don't know how much is it, times 100. Right, so press this in your calculator, and most likely you are going to get 1200 watts, somewhere around there. You're You're gonna get 1200 joules first, guys, but it's because this is in every second, so it is equivalent in power as well, guys. I repeat this, why can we find power here in this scenario is because this 4150 is in terms of seconds, guys. So it's 4150 divided by 1 second to change it into 4150 watts, which is the power. All right. 1200 looks a bit small. Oh, sorry, I've mistaken this for another question, guys. This is in 5 seconds. Sorry, my bad. So you're supposed to convert this into energy into power first, which is 41500 divide by your 5 seconds. Right, guys, I made a mistake. Guys, pay attention. I forgot to include this piece of information, which is 5 seconds. I assume that this was in 1 second, which is clearly wrong, right? So you're supposed to convert power into the energy into power first, which is 4150 divided by 5, which you're going to get number 830, is it? 830 watts.
Wait, what?
Right.
1179.
Oh, 1179.
Yeah, 1179.
Oh, you'll get 1179, is it? Yeah, correct. So you're supposed to substitute this into this way, guys. The output, this one is supposed to be output. Then you find that it is 70 equals to 830. You're gonna get 70 equals to 830 divided by your input multiplied by 100%, which at the end of the day you're finding the input. Oh, hello.
Joker.
Yeah, sorry. Now your input, if you do your mathematics correctly, will be somewhere around 1200 watts, correct to 2 significant figures. Okay, everyone. Anyone confused with this? Anyone didn't get this answer? Anyone lost in the woods, guys? Yes, Brian, where you lost? The whole thing? Which part? Which part? Okay, guys, if you have no questions, start attempting question 2. Question 2 is nothing new. It's the same thing. Try to do it yourself this time, guys. Brian, which part are you missing? Which part did you? This is power. This part is just power is equals to energy over time, because this one that we calculated is in energy. Right. So I want to convert it into power because this one wants me to find power, right? So it's energy over time, which gives me this power. This power is the output. Okay, then after that, I substitute 70% into here. This 800 over into here, that I'm finding the input, so I don't know what it is, times 100. Guys, one more thing I want to highlight, when you times 100 here, don't pandai, you click the percentage button in the calculator also. It will make the whole thing wrong. When this percentage is units, it's not a symbol for you to press into a calculator. So you're supposed to just times 100 when you're doing this calculation here. Don't press 100, then the percent sign into the calculator, it will be wrong. Okay.
So every time there's presentations.
Yeah, don't press it in the calculator. It will be wrong for sure. Okay, guys. Another 8 minutes. Let's go. Hey, okay, everyone. I think you have sufficient time to try it out already. Let's go through the questions real quick, guys. As I stated just now, this is a very, very common IGCSE question. They'll ask you to define what specific capacity is. And for those who weren't paying attention, this is your last chance. You're supposed to make it into the subject first, right? Using the Q equals to MC data formula, make C the subject. And from here, you're supposed to say that it is the amount of energy needed.
Yeah, those add amount different energy needed.
Oh, sure. It's the same thing. Energy needed to change 1 kg of a substance.
1 degree Celsius.
Excellent. By 1 degree Celsius. A very standard question with a very standard answer for sure. Yeah. Raise can also basically changing it now.
Yeah.
Right. Hey, it is very important for sure. Okay. Okay, then finally, the next part here, you're supposed to calculate the specific capacity, guys. Anyone still finding it hard to find 950 kg, sorry, joules per kg degree Celsius now? Anyone cannot find this, please raise up your hand now, including those who are online.
So I thought the
Second change to minutes 睡觉没了.
second.
What the hell? Second is always in seconds. Time is always in seconds, never in minutes, never in life. Okay, guys, for those who did not get this, please pay attention here. First and foremost, you're supposed to identify that this is your mass, this is your power, this is your time, and your change in temperature is essentially 21 degrees Celsius. Right. Right. From here, if you're asked to find specific capacity, Q is equal to MC theta lah. Right. So if I'm looking for specific capacity, I need this, and I need this, ma. Right, Sydney. So from here, I first and foremost, I don't have my energy. But when I don't have my energy, I realize that I have power and time. Right. From here is essentially using the formula power is equals to energy over time. Energy is equals to power times time, which is essentially 420 multiplied by 95. Whatever this number you have, this is your Q. Whatever it is, I don't know what it is, but you substitute it on. Then after that, with that, you have this, you have the mass, you have the change in temperature. It's just a matter of algebra only, right? So C will be equals to Q over M theta, which is whatever this amount is, I don't know, right? Divide by your 2 kg, divide by your 21 degrees Celsius. So whatever this amount is from here. Press it in your calculator and you will get somewhere around 950. Somewhere. Yes, the SI units for time is always in seconds. The SI units for length, any length is always in meters. And the SI units for temperature is for sure degrees Celsius. Okay, everyone? Daddy? Is that you, Daddy? Okay, yeah. Then after that, hey guys, this is also a very, very common IGCSE question, guys. I want to emphasize this. When you see anything to do with heat, guys, anything to do with heat, whatever number that you calculated here, this is like the perfect world scenario. It doesn't really exist. Why? Because this calculation is assuming all the energy is 100% converted into the mass, which is going to raise the temperature. In reality, you know for a fact that heat is going to be lost to the surrounding. Even before reaching the cylinder, the metal cylinder in this case here, the energy would have been lost to the surrounding, right? So, and anytime you're asked to improve the accuracy of any heat temperatures is always to reduce the energy loss. Your ultimate goal is to reduce the heat energy loss. And if you want to reduce the heat energy loss, it's always a standard 2 answer, which is to add insulation onto whatever the thing is. In this case here is the metal cylinder, the aluminum cylinder, and of course add a lid on top of it, an insulation lid, right, which is essentially preventing convection occurring, guys. So these are your 2 standard answers which you must know for sure. Come on, if they ask for all this heat. Yeah, around the aluminum cylinder, and the second one is put an insulating lid onto the aluminum cylinder. Nope, it's not. It is not. Insulation is around, then the lid is on top. Is it?
Really?
Yeah, but it's a standard answer. It's already standard answer. Huh? Same thing lah, insulated insulation. Yeah. The thing is they are going to mark and see if you understand what's going on or not. They're not looking for wordplay. They just huh? Oh yeah, add a lid on top to prevent convection. Okay, and then the bane of all students, which is thermocouples here, guys. What's a thermocouple? Oh, yeah, before you guys begin now, what's a thermocouple made of again? And what are the components? It is made of a galvanometer. For those who do not remember what a galvanometer is, it is essentially a millivoltmeter plus a milliammeter. It can measure very small changes in voltage and also current. Standard, right? This galvanometer will be connected to very good. To what? Hot and cold junction, very good. And then after that, will this metal be the same? No, it must always consist of two different metals. If this is iron, then this must be copper. If this is constant, this must be aluminium. It must be different metals, guys. The purple one and the green one must be different metals. Very, very, very important, right? But in this question, they don't ask extensively on this thing, right? Yeah, then after that, I also want to state what is meant by sensitivity and what is meant by linearity. Guys, sensitivity is basically the ability to measure small changes. Guys, for example, a micrometer screw gauge is definitely more sensitive than the ruler you carry around in your pencil box, right? Because the micrometer screw gauge can measure, small changes in the temperature or reading or whatever. Okay, to be sensitive is to be able to measure small changes. It doesn't matter if it's temperature or length or whatever, right? And to be linear, guys, to be linear is to have equal spacing between each of your reading. A linear what's it called, ruler will look something like this, right? The spacing between each and every one of it is quite the same one. A non-linear one will look something like this. You'll see that the spacing is increasing more and more and more. This is non-linear. This is linear in terms of your reading in your measurement tool. Okay. Yeah, try to attempt this question here. You probably only need 6 minutes for this question. So let's go. Okay, everyone, let's go through the questions together real quick. Guys, if you look at this one here, the first and foremost is that you'll notice this is a thermocouple, right? And if it's a thermocouple, you should have a rough idea of how the whole thing looks like. This meter Z should be your galvanometer. This point and this point here should be your hot and cold junction. It means to say this wire and this wire is the same, whereas this wire must be different, right? It is good to imagine what's going on, then you'll have a clearer idea of how to answer this. So obviously, the first thing first is you can measure potential difference, because it's either millivoltage or milliamperes, right? Then after that, X and Y are different materials for sure. They must be different materials. If not, the whole thermocouple will not work, guys. And of course, X and Y are electrical conductors, because it must be a metal. They must be different metals, guys. All right. So I think most of you guys should be able to get this one. Right. Then after that, the next part, which I see everyone struggling with, right? And then there is actually a very standard answer for this, guys. If you look at this question here, they'll say that in a liquid thermometer is replaced by similar thermometers with a larger bulk. No other changes is made. Guys, what do you think is going to happen when a larger bulk is here in terms of the sensitivity? Will this, it'll be more sensitive. What's the reason behind it? Is because larger bulk will have more liquid inside the thermometer, which can shoot up the thread even more. Guys, this is the reason why a larger bulk will increase the sensitivity. So your statement is going to be somewhere along the lines, sensitivity definitely increases, and your reasoning is because there is more liquid. There is more liquid to move up the thread. 那个 bulb, you know the bulb that you put, you know that thing, this thing, the thermometer, this thing, this is the bulb. You know the bulb that you put to measure the temperature one. There is more liquid to move up the tube.
Wait, the water is stored inside the bulb. I mean the mercury.
The mercury is stored inside the bulb for sure, yes.
Also, when it's 0 degrees Celsius, all the mercury is inside the bulb.
When it's 0 degrees Celsius and 100 degrees Celsius, the mercury will still be inside the bulb.
No, it's 100 degrees will start.
Oh, yeah, you could say that, but it's a very weird statement. No one will test your understanding of that. Okay, then moving on to the next part here. A capillary tube in the glass thermometer should be constant diameter. But if you look at this one here, there is a malfunction. The tube is becoming thicker, right? Then after that, state and explain the effect of this fault on the linearity of the thermometer. How is the linearity going to happen?
Not uniform.
Yeah, it'll be the linearity of this thing is definitely going to decrease, right? Why? Because there is non-uniform liquid moving at different sections of the capillary tube, guys, which is obviously not going to give you equal spacing between the reading, right? So your statement is linearity decreases here. Linearity decreases. Non-uniform amount of liquid moves through the tube. Okay, everyone? Anyone confused with this part? Anyone's got any questions that are uncertain of? Not constant linearity, for sure. Yeah, can acceptable. So on. What?
What is linearity?
I just said equal spacing between each reading. Like for example, your ruler from 0 to 1 and 1 to 2, 2 to 3, the spacing shampoo is the same, right? That is what we call linear spacing. That's linearity. But if it's, the spacing is different, it's non-linear. Hey, everyone, do question number 5. Do question, skip 4 and do number 5 first. Because I want to go through this with you guys. Good. Hey guys, listen up. You know the temperature time graph, right, of a melting ice. A temperature time graph of a melting ice will look something like this. It will always flatline somewhere in between 0 and 100 degrees Celsius in terms of the temperature versus the time. Why does it flatline, guys? Yes, good. It is to break the bonds, guys. Energy that is used to increase the temperature here is being absorbed by the bonds to break them, to change them from one state to another. Meaning to say, you know how you have always been calculating Q equals to MC theta, right? It is only applicable in this line, and also this line, because there is change in temperature here. For those that do not change in temperature, which is this line and this line here, you're supposed to use the Q equals to MLF or Q equals to MLV. Guys, LF stands for latent heat of fusion. LV stands for latent heat of vaporization. Okay, guys, let's pay attention to this. They always ask this in your IGs. They'll ask you what's the latent heat of vaporization and what's the latent heat of fusion. Guys, latent heat of fusion and vaporization, the key word, very important, the key word is you cannot have any change in temperature. So like what we did for specific capacity, you're going to make it into the subject first, is Q over M, right? With Q over M here on top of what you're going to explain now, which is latent heat of fusion, is the amount of energy needed to change 1 kg of a substance from solid into liquid without any change in temperature. Keyword is there is no change in temperature. Without the word no change in temperature, you will not be awarded your second mark, guys. Very, very important. I repeat this again. Specific latent heat is the amount of energy needed to change 1 kg of the substance from solid into liquid without any change in temperature. Very, very important. Also, always ask in your IGs.
Is it always solid? What is the?
Oh my god. It could not, it won't necessarily be solid to liquid. Let's say, for example, if they ask about latent heat of vaporization, that is not going to be solid to liquid law. In this case here, latent heat of vaporization is the amount of energy needed to change it from from liquid into gas state without any change in temperature.
Right. Fusion cannot only like solid to liquid, cannot liquid to solid.
Yeah, fusion is for sure solid to liquid or liquid into solid. Fusion is the change between solid to liquid or liquid back into solid. That is fusion. Vaporization, vapor, there's gas in it, right? So must involve the gas component here. You got it, guys.
Yeah.
Yes, please attempt question number 5. It is a more interesting question.
Yeah, it's okay.
Can you repeat about the fusion here? Let me type it out for you. The amount of energy needed to change 1 kg of a substance from solid to liquid without any change in temperature. This is the statement, Sydney. Yep. Good. What's the units? What's the formula? Joules per kg, very good. I'm not sure of anything anymore. All right, everyone, due to the time constraint, let's go through the questions real quick. Everybody, shut up, pay attention. I don't want to be speaking in the front and I got to overpower the voice at the back also. Okay, so I think this one here, I don't explain now. I already written it down in the chat already. Everyone should at least know this by now. Right, then let's go through the next question here. Ice cubes of total 70 grams at 0 degrees Celsius are put into a lemonade of mass this amount. Okay, so there's two masses here. This is the mass of the ice cube and this is the mass of the lemonade. And it starts off with 0 degrees Celsius. All ice melts as 23,500 of thermal energy transfers from the lemonade to the ice. The final temperature of the drink is still 0 degrees Celsius. Calculate specifically the need. If there is no change in temperature, then naturally the only formula is going to be Q equals to MLF, right? In this case here, LF would be equals to Q over M. So my question is, which is the M? Is it the 70 or is it the Y? Good. It is because it is the ice, guys. So you're supposed to use the 70 instead of the 300. How much? 336 joules per. No, it's not. Grams. Why? This 70 is in grams, right? Don't. If you change it to kg, then it's acceptable. Then it will be a totally different answer already. It'll be a damn big answer, right? I think.
0.0009.
Yeah, damn big. But it's acceptable. You have to be careful with the units, guys.
It's a must be. Yeah, it's the SI unit.
Yeah, I know. But in this question, they accept it. They accept you, but you have to specify the units. That's why I keep saying that the units are very important. If you don't write the units, you will be penalized for sure. Okay, then from here, now for specific heat capacity, right? You see, obviously the Q equals to MC theta formula in this case here. And if I substitute everything in, I think it would just be like 23500 equals to your mass of the ice, which is 0.3, multiply by a specific capacity, multiply by 19, right? So this is yet again an algebra question here, which is how much? 4120. What's the units here? Yeah, Joe, this one will be in kg, guys, because I converted this into kg. The 300 grams is converted into kg, guys. It's just a matter of algebra only, guys. All right. Anyone couldn't get this calculation? Anyone? Anyone cannot? 4120 joules per kg degree Celsius. You could leave it in joules per grams degree Celsius, but be careful with your working. If you use 300 here, then you just joules per grams per degree Celsius. Okay. Okay, then final one here. Guys, this is a keyword. I want you all to pay attention to this. You see this word, as soon as you see this word, the melting ice floats on top or sink. If you talk about float or sink, straight away you should ask yourself in terms of density already. Because in terms of density, less dense will float, more dense will sink, right? So in this case here, they ask you to explain the process by which the lemonade at the bottom of the drink becomes cold.
Isn't it convection?
Yeah, but this convection is due to density. What? You know how convection current occurs, right? It is. Huh?
I start my sentence with making convection.
Oh, this is definitely going to be in terms of convection because they mentioned the hot and cold one. But I'm telling in general, if you see this word float and sink, it is definitely testing your understanding of density. But in this case here, convection is an application of density. The reason why hot particles rise is because they are less dense, and the cold particles will sink to the bottom because they are more dense, guys. So you're going to basically say convection current occurs here, right? Convection current occurs here. Oh shit. Current occurs. The hotter particles, which are less dense, will rise. What do you write? To the top. Wow. Older particles. Wait, sink to the bottom. Something along this line. It doesn't have to be word by word, guys. In fact, I think the mark scheme doesn't Go word by word also. Also what?
Convection and hot air rises while cold air sinks.
Sorry, say that again. Sorry, say that again. I wasn't paying attention.
Convection happens and hot air water rises while cold water sinks.
Yeah, that's acceptable as well. Yeah. Yeah. Like I keep saying, guys, this is not an English exam. They will not test your understanding on the comprehension or whatnot. They will, however, test your understanding on what is going on. You need to know what is going on instead of just memorizing the answers. Okay, convection current occurs. The hotter particles, which are less dense, will rise to the top, while the colder particles sink to the bottom. Oh, my words is a bit ugly though, but everyone's getting used to it. Okay, everyone. With that, I beg you all goodbye for this week, guys. Yeah. Bye bye. Sorry. Stop this first.